The base of most musical systems is the octave. When two musical notes are an octave apart, the frequency of the higher note is exactly half the frequency of the lower. Two notes that are an octave apart are exactly 1 unit apart, under a logarithm of base 2, and they are given the same letter name according to a practice called octave equivalency. Because notes of the same name occur every octave, musical notes can be organized cyclically. In his videos, Dr. Baker introduced the chromatic circle, a clock-face circle that divides a single octave into 12 equal half-steps, or semitones of pitch. By convention, the circle starts with C at the top and proceeds clockwise from C to C sharp, to D, D sharp, E, F, F sharp, G, G sharp, A sharp, B, and back to C. The circle of fifths is similar in that it places all of the semitones in an octave onto a circle with C at the top, but the circle of fifths goes in a different order. The order of the circle of fifths is given by stepping up 1 perfect fifth, 7 half steps if you're using an equal temperament tuning system, to the next note. In this way, the circle of fifths is filled using additions of 7 modulo 12. The fourth is the other perfect interval, after the fifth. While a fifth is 7 half steps, a fourth is only 5 half steps up. Because 5 is congruent to -7 modulo 12, intervals of 1/4 can also be used to populate a circle called the circle of fourths, which is the same order as the circle of fifths, just backwards. The perfect fifth and the perfect fourth are the only intervals besides a single half step that will give a cycle that includes every note in the chromatic scale, and it's possible to use them to generate the other intervals in the chromatic scale. The minor second is congruent to 7 fifths, or just 1 half step. The major second is congruent to 2 fifths, or 2 half steps. The minor third is 3 half steps, and it can be formed with 9 fifths, or 3 fourths. The major third is 4 fifths from the starting note. The tritone, the interval between the perfect fourth and the perfect fifth, is 6 fifths and 6 fourths, and the minor sixth is 8 fifths. The major sixth is 3 fifths, or 9 fourths, and the minor seventh is 10 fifths. The last interval, the major seventh, is 5 fifths. These other intervals, aside from the minor second and the major seventh, which are both equal to jumps of just 1 half step, are not like the perfect fifth and perfect fourth. You cannot cycle through the entire chromatic scale using intervals other than the fourth and fifth, because those other notes will return back to the starting note before hitting all 11 other notes. The interval of 1 whole step is equal to 2 half steps, and the period of the cycle it creates is 6. Starting from C, the notes included in the cycle are the interval of 3 half steps, or the minor third, has a period of 4 modulo 12, and produces this chord. The major third has a period of 3, and the tritone has a period of 2. They produce these chords. The minor sixth has a period of 3, and it gives the same notes as the minor third, and the major sixth has a period of 4, and it gives the same chord as the major third. Likewise, the minor and major seventh correspond to the minor and major second. The reason why the perfect fourth and the perfect fifth have this property, where they hit every other note in the octave before returning to the starting note, is because 7 and 5 are relatively prime to 12. The major seventh, which is 11 half steps and is also relatively prime to 12, also cycles through all the other notes in the octave before returning to its starting note, but it doesn't produce the same interesting permutation that the fourth and fifth do. It just sounds like descending half steps. The period of the cycle for an interval of the chromatic scale, divided into 12 half steps, is 12 divided by the greatest common denominator of 12 and the number of half steps in the interval. Some musical systems do not divide the octave into 12 parts. Each of the semitones in the musical system we've used so far has been defined as 1/12 of an octave using logarithmic units called cents. In this 12-note system, there are 100 cents separating each half step. Other musical systems divide the octave into 5 or sometimes 7 parts. The notes in a 5-part octave are 240 cents apart, and those in a 7-part octave are 171 cents apart. Since 7 and 5 are prime numbers, any interval of notes, when added together in the manner we've been using, would cycle through all of the notes in the octave before returning to the starting note, and each would have the same period.